Good morning, everyone, and welcome to Empower and Engage Your Students in Math and Science through UDL. This is presented by John McGowan. John is a certified Google education trainer and the creator of GMath, which had over 13 million worldwide users before it retired in January 2018. After teaching math for over 15 years, he joined TextHelp, and with the goal of making digital math easy and accessible to all. Equatio is the very first step in that journey, and we are so excited to have John with us today. He is going to tell us all about this Equatio program. I've been talking about it all morning. You're probably sick of hearing it from me, so let's just bring the expert on and let John take it over this morning. Good morning, John. How are you?
Good morning. I'm doing amazing. Thank you so much, Lori. I love that your coffee passion that really matches up with my enthusiasm. So I'm super excited.
Yeah, all right, so I'm excited to go.
Great, thanks. I'm excited to have all these blended citizens out here as well. I know it's Cinco de Mayo, so I'm actually over here in Ireland, so it's a little later in the day, so I have some of my neighbors drinking some Vino Rosso, I think. So I'm really excited to share time with these amazing educators. So thank you for sharing your day with me. And like I always say, as a former teacher, my wife is also a teacher, that teacher time is your most valuable commodity. So please, I'm so happy that you're willing to share it with me. So am I audible right now? Everybody can hear me well?
Yes, John, you're good.
Great, thank you so much. Sometimes the transmission over the Atlantic doesn't work so great. So I think, what am I here today? I'm here to talk about the state of math. Like, one of the biggest things is math is cumbersome to type, as Lori already referenced. There aren't keyboard keys for most of the things. And that was the big driver for me with my students in my classroom. I love the collaboration aspect. I was using digital whiteboards, all these different things. I just really wanted them to engage in the content, but it was hard for them to use the Google atmosphere. So that's why I learned how to code. I made GMath, and that kind of drove my passion. Once I saw that students were enabled to communicate in the method they prefer, that really drove the engagement up in my classroom. And as teachers, like, that's what we need. We need students to be engaged, and then we can work our magic. Because I do believe that it's all about having that magic. It's a craft. You know, we want students to be enticed, and I think that's the really biggest thing to get students involved in the classroom. And so also, math is important, and we've been teaching math the same way for a long time. Like, honestly, my high school math experience didn't differ much from this picture. Like, this is back, who knows how old this picture is, but literally I was writing down on a piece of paper and pencil. And I was kind of baffled when I first got in the classroom. That was still kind of the way that it worked. Now, I want to make sure that it kind of shifts beyond that. So what are some of the benefits in using technology? So here, if you're here on a Saturday learning about this craft, I know that you want to engage your students. And so technology is really a way to enhance it, make it better than just, I want to make it different, not just digital. You know, paper is great for some things. And so I want to make sure that we don't just have everything go digital, but when we do, we encourage students to work in groups and collaborate, and all those skills that they're going to need for their careers and their jobs. I have a daughter who's 4, and that was really the big driver for me to continue to develop GMath and kind of work with Equatio, because her life is going to be working digitally with someone around the world collaborating, and she might not even know them. So that we need to make sure that our students can collaborate and work digitally in the classroom. Additionally, as a teacher, we love multiple representations of math concepts. I mean, that was one of the biggest things I learned was with algebra and 4 representations of a function. That was like my mantra, to get students to really be fluent and understand multiple representations. So the technology, I love Desmos, bringing in graphs, allowing them to communicate their thought process is really the goal that we want students to get to. And technology enables me to be more efficient. I like to work smarter, not harder, because we all know that teachers, I mean, we work as hard as we can. We can't clone ourselves in the classroom yet, but technology can kind of make me more effective, because I can give this rapid sharing, I can give teacher feedback, I can use scripts, and all of these things can make me give students feedback faster, which means they're more engaged in the content, and then they will be more adept to opening up that communication between me and them. And that is where that teaching happens, where we all have our own flavor, we're all artists in our own way, and then engagement is a prerequisite for that learning to go on for the student. So I think that's kind of also like everything that we have behind Equatio. You know, students come walking into the math class directly as like a combatant. They're battle hardened, they're ready to fight this thing called math, and it shouldn't be like that. That's how I feel like a lot of the digital math is. It's hard to use. we as math teachers are used to using these palette-based editors where we find the picture of the math we want to make and click that button. We're trained to do that, and we like to do that, and most of us. But in the same sense, my students hate to do that. So we build Equatio to be this easy to use math editor, math and STEM editor. I don't want you to have to learn some code for you to be able to just represent your thoughts online. So that's really what I'm excited about with our prediction, and then also with our UDL principles. So that UDL process, like honestly, I didn't learn it until probably my last 3 years of teaching, when I was learning about multiple modes of impact and how students can choose and how they want to respond, which method that they want to respond in. Because I realized I was dictating the mode of communication. If you are not writing it down on a piece of paper and submitting it back to me, I was telling them I'm not validating this communication method. I was not validating how they wanted to respond. I would take a verbal conversation and use it for formative feedback and say, oh yeah, you understand it. But if they didn't write that down on a piece of paper, I would not reflect that in their grade, which is an inauthentic wet representation of their knowledge. And so I think being able to allow students to respond using UDL methods really enhances that validation of what they learn. And that's great for all classrooms, because more learning is going to go on, because students will be taking more leaps of faith. They're going to be communicating multiple thought processes and multiple ways to see a problem, hearing from their peers. It just brings in all of these great teaching skills that, as math educators, that we love. And even in the science classroom, I say math all the time because that's I default to that language, but STEM, the entire STEM field has that same pain points. They're cumbersome notational things to do, hard to bring in digital and take that same computational thought process. And the third tenet of Equatio is we tie in seamlessly with read and write. So that's the biggest thing, is we get that good magic and make it audible so that we can hear the math or science being read aloud. And so that's a great from learning process, and then also just for students that require that accessibility. So many tools that I use now were built for accessible technology because it just makes life easier. So I think that's the big thing about Equatio, is we want to bring it in and just make it easy, eliminate those pain points, bring down those barriers, and allow students to respond digitally, and that will enhance the classroom. So that's really the big goal that I have for Equatio, is just make it easy to communicate, because the heart of that process is what we want as teachers. So where does Equatio work? We work in the entire G Suite. It's a Chrome extension, so it works in Google Docs, Forms, Slides, Drawings, Form Responses. So it's just a really great way. If you're in Google, it works. We also have an installable app that works for Windows and Mac and inserts into Microsoft Word. So all of those same UDL tools inserting into Microsoft Word. And then our third integration is this Equatio Math Space, which is a digital whiteboard that was built to do STEM. And on top of that, we layer a bunch of feedback tools and accessibility as well. So that's kind of, I wasn't happy with the ability to create content still. And my development team laughed at me because I would say how I'd print something out, and then I would literally get scissors, cut it out, and then get some tape and tape it into where I wanted it for the test. And then I'd make a copy, and then I would scan it in, and then I'd have the PDF, and I'd make more copies of that and staple it and give it to my students. And they'd laugh, and they're like, oh, you must have done that when you were like in your first year of teaching back in 2004. And I say, no, that was like what I did the last thing before I joined TextHelp, was the final exam I gave in my classes. Like, that is quote unquote state of the art, like literally physically cutting and pasting. And so we want to make it so we can make things digital and then also make them editable. And so all of these UDL processes, this multiple ways that students can communicate and get it to be digital, is how we're building in. So we're transforming the STEM classroom with prediction, LaTeX, handwriting recognition, speech input, mobile image recognition, the Desmos graphing. We can easily make some shapes, and we also have a Spanish localization for those Spanish-speaking students who can communicate what they want, but they can't use the English notation for it or the English vocabulary. We can make that fully localized into Spanish for them. So instead of using prediction for square root, they can just type RA for raíz cuadrada, and they could represent the square root symbol in Spanish. And then it had to be read back to them in Spanish. And then the last thing I really want to get to is the heart of this. It says underlying math and math and math, but it's really STEM. Like the two things on the left, math notation and math terminology, for every other thing before Equatio were prerequisites to getting their thoughts digitally. If you needed to know the math notation to be able to find that button to click, otherwise you can't make a square root until you know what the square root symbol looks like, because you have to click the button for the make a square root. So that's why we say, well, if you know the terminology, type that phrase in there. We make it easy to type that phrase and represent the math in there. So you don't have to know both. You can know one and kind of learn the other as you're going along. And that gets you to the heart of that underlying STEM concept. And so I really want to know the square root of 4. Can you tell me one number that multiplies by itself that gives me 4? So those notational component and the terminology were getting in the way. Those were barriers to representing thoughts digitally. And so that is what we're eliminating with Equatio, so we can get to the heart of that, understanding the concept and what's behind it. So I have these slides that I'll share, but I'll kind of go through them essentially. Just what does it do? Google Docs, my students are familiar with Google Docs. They use them in other classes. And then it's great for teachers to provide feedback through the Google comments. I love the voice comments. And this is where our prediction lies. So this is really a great venue for students to learn. I love Google Forms. I use them for warm-ups. Other people call them bell ringers, exit tickets as well at the end. It's great for formative assessment for me at the beginning of class. I just love Google Forms. It's also great for summative assessment. All these great things that I do as a teacher, Google Forms is where I save the most of my time because I can assess more quickly on the back end. So it might take me a little bit longer to type up my problem versus writing it out by hand and then making paper copies. But instead of me collecting a stack of papers, I can use the power of technology to help me assess quicker. I can use copy and paste or some pre-canned comments to give my feedback, better feedback to my students faster. And that's where I really amplify and save my own time and make me a better teacher by using that those assessment responses. And then slides I love is the best way to interact with, and I think it's the best teaching medium for math and science. It's less rigid. Google Docs is built to type prose, there's paragraphs, indentations. I don't care about those as a STEM teacher. I want to have the flexibility to move things around and not be limited to typing prose. And so that's why I like to teach through slides. As my friend Alice Keeler always says too, like it's great for, slides are free, have students take their own and everybody can work on their own slide. Then you have a slide deck of 30 different perspectives on a problem equally in there, and students can, it's not dictated to me showing them the content. They can see what their fellow students are explaining with their own thought process with slides. So the UDL input methods, I'll show you the Equatio Mobile. I'm super excited about. I'm on my Mac right now. I also have a touchscreen Chromebook, but my Mac's not a touchscreen, so I can use a touch device like my iPhone or my Android phone or my touchscreen Chromebook to be able to respond and digitize that math and put it into my G Suite or the Equatio Math space. So really, again, a lot of it is about making it digital. And then once it's digital, it's accessible. We can use powers of technology like copy and paste or computation, all these things that once they're digital, then we can really leverage that power of technology. So I'll show the Equatio Mobile. Speech input is really great. I can speak much faster than I can type, so the speech input really helps me to do my get my thoughts down. The prediction method, again, the same thing. It's not a requirement for me to know the notation. And on top of that, we put the prediction terms with the notation next to it, so they can learn the terminology along with the symbol, which is great for making and cementing those concepts to have my students understand those as well. So they're learning as they're explaining. And it's great for chemistry notation. Those are cumbersome notational things. If they're cumbersome notationally, we can do that with prediction. And we have a lot of formulas in there that I'll show you in my demo. Handwriting recognition, like I said earlier, paper and pen is best for a lot of things, but here we can do that handwriting recognition to make that so we can digitize it, then it can be accessible, then it can be editable much more easily. Also, if I could submit those in Google Forms, that's best for me as a teacher to amplify my digital workflow. I think Desmo's shift in my classroom teaching by far with the visualizations that I can impact with sliders and all their activities. They're awesome. We integrate those directly wherever we have Equatio. So anything you made on desmos.com/calculator, you can just take and import those into Equatio and put those in the G Suite. It's just really great for students to be able to interact with those visualizations and learn concepts. And then our Windows and Mac thing, literally it's the same, it inserts the same UDL tool into Google Docs into Microsoft Word instead of Google Docs. So really branching out on that. Yeah, so now I'm gonna jump into my demo time so you can see what I was talking about. So here in a Google Doc, the biggest thing about Equatio, it's a Chrome extension. So I just click on the little Equatio button anywhere I'm in the G Suite and the little toolbar ribbon pops up on the bottom. And those are my input tools. So first I'm gonna start off here with the speech input because I think it's the most magical. Once I do, I just have to click on this start speech input and it's gonna say what it thinks I'm hearing. We use some Google Artificial Intelligence. So sometimes it's not thinking it's doing math. So you'll see sometimes it changes, but it'll render the math over here that it thinks it hears and I can then correct it. So 3x squared minus 14 equals 10. So I can literally just make that. For those students that don't know what squared is, they don't know that it goes in the superscript, that's just easy for me to make by speaking it. And then now it's into my document. And then the best part about that is it's also accessible. So Read and Write can now read that aloud if I want to. It'll make it nice and easy to read.
3x squared minus 14 equals 10.
So I know sometimes in webinars that doesn't come off the best, but literally it reads aloud as I want it to be read as a math teacher. So again, that note, students can hear that cements that that's the squared component. So they can learn the notation as they hear it aloud in that accessibility part. So I love that speech input for getting students to put that in there. Another thing I think it's great for is younger students. My daughter likes to talk to it all the time. And so 3 times 4 equals 12. So that multiplication symbol is really difficult to type. It's not very easy. There's no keyboard key for it. It's hard to find, and it makes it easy for younger students to respond and make their some of that notational component easily. If I wanted to, I can come in here and use my prediction now. So if I wanted to do some other component, I can do that with prediction. So I'll just show that straightly from my equation editor, which is where all our prediction options are. Also, the blue box, your options, you can turn on other prediction items like chemistry and formulas. But the same thing, if I wanted to do 12, so I can start typing 12 and then divided by, I can just start typing DI and it brings to those notational components. So I can say divide 4 and then equals 3. And so I can utilize those ways to represent my thoughts, whether it's a basic arithmetic thing or I can go really as complicated as I want. So for instance, again, that square root thing, if I wanted the square root of 4 over 2, usually, if every other equation, I have to think, do I make the fraction first or do I make the radical first? So I can literally just start typing SQ, get the square root, put my 4, and then I can just start typing OVER, and that will take and put everything before that in the numerator. So square root of 4 over 2. I didn't have to think about it. That really reduces the cognitive load for students who are just learning about these concepts as well. And I think that is a beautiful part for them to be able to represent their thoughts without having to think about how do I make this structure up? So there's no planning that they have to do. They can just start working, and I can start typing minus. I can copy and paste. So I can copy that whole thing and then paste it if I want to do like a square root of 8. And so now I can just start working from there. So I can say I want to insert that. And then now I can just talk about, well, what will my next step be? So I can then, again, use copy and paste. So I can copy this and then take that whole part, delete it, put it up here and say that's going to be minus, and then paste the square root of 8. And so all that part and process just makes it more simple. And my students will show more work. So that's really great that they don't have to worry about what those look like. They can access these much easier. I found so many mistakes that my students made were transcription errors. They would copy from one line to the next, and a number would, like an 8 might turn into a 9. And it was just because they copied it down incorrectly. So here it's saved in there, and they can just use that copy and paste to give me multiple steps. I see that most when I reference a formula first. So our formulas are built in here as well. Like the quadratic formula is really a difficult formula to type, but I can just type QU, get that prediction, hit enter, and then it inserts automatically. And then my students can work from there. They can say, well, what is it B? If B is 3, now I can just literally see wherever I see that B, I can put that 3 down. And maybe I want to put parentheses around it. So I highlight it, hit Shift 9 to start the parentheses, and we automatically put the other parentheses after it. So it's really just this almost physical way to show that the representation is. I always say I have a big thing on my wall when I teach algebra that equality just means it's interchangeable. So they're physically interchanging things, which cements that process, that mathematical concept of equality. They're literally copying and pasting and replacing. So that helps with that learning process as well. So the technology is amplifying the student learning. So all those things I think are really great. Finally, on top of those, we have a handwriting recognition piece. So again, I was saying on my Mac, and the touchscreen doesn't work because Macs don't like touchscreens, but I can literally just say that's a 3x squared minus 14. And so you can see as we go, it typesets it. And then if I would say I didn't want that squared, I could just scratch it out and then delete it. It didn't scratch out well enough. There we go, that should work. It didn't want to, it keeps thinking I'm doing a 2. I can just scratch out my number and it will delete that. There we go. No, it still didn't like it. So we'll just assume that it did that well, but it's a fun thing when we scratch it out and it deletes it. But so if I had that 3x squared, the fun part as well is I can then take any of this and pop open Desmos, and it automatically will graph those. So 3x squared is still remember that. I can literally just insert that. So I went from something physically and handwritten. Maybe I have no idea what 3x squared is, but I can see that graph. So I think that's really great. I could also extract that and work from there. And if I wanted to, I could make that a variable, and then I could give this to my students. So I could ask them what happens as A changes. They can literally play with that slider, and then they see that, oh, something happened there. And so I can use that notice wonder, like, what do you notice is going on here? What do you wonder? Why are things going like that? And I can prompt them to think about it versus me just saying like, oh, hey, for A for a quadratic talks about the concavity. With a few minutes of discussion, they're going to come up with that on their own, and them discovering that learning is much better than me speaking and telling them what that learning process is. So now if I share this Google Doc with my students, they click on this, they extract it, and they get to play with that variable. They get to play with all of that. So that's the beauty on that. And on top of that, it's accessible. I can literally just hit Command T, and the audio traces on there, so I can hear what that graph sounds like. So again, I just think is super cool to be able to hear what that sounds like. It's going up in pitch. So all those ways just to make it more digital. So now they're interacting in Google Docs, like with the amazing collaborative pieces. If I'm using Google Classroom, they're sharing through these. So all that amazing part about the Google G Suite, we're just laying on top of that and having just more ways that they can be blended citizens and just be working here in the Google G Suite on top of that. So Google Docs is great. It's a great way to start teaching. I also love the voice comment and read and write. So if I click on this voice note, it'll literally be me explaining with my own voice. A means the concavity. As A goes negative, then it flips upside down. So I can literally insert that as a Google comment, which is great for my students. They can give me a verbal explanation that's attached to some sort of STEM concept that they provided. So I love that part where it just inserts directly. It's a Google Doc comment. It's tied to that. They can hear it be played aloud. They can resolve it away, and then they can always go back and find it because it's hidden in these comments. So they can reopen those and then hear that voice. So it's a really fun way for them to find their voice, to be able to hear their own voice in that comment. And it's great for me too. I can give them advice. I can say, you know, don't forget to whatever hint I might want to give them in person. I can give a digital hint. Finally, the last thing I want to show in the equation editor before I jump into Google Forms is our chemical notation. So I start typing ALU, and I can make aluminum diacetate or aluminum triacetate. And that's a cumbersome notational component that prediction makes easily. We also have all of our arrows in there. So if I want to make a yield, I can do that. So again, if you're working with chemical notation and formulas, we have like the ideal gas law in there. All these functions and formulas we can make in there that are, if they're cumbersome to make. My favorite is I taught AP Stats for a long time. The correlational coefficient, I never want to make any student have to type that up, so they can reference it, use it in practice with prediction. So we have tons and tons of prediction formulas. And so I think that's a great way for us to make that notational component. I didn't show the LaTeX tab. I don't want anyone to have to do LaTeX. If you know it, great, you can use it. It's pretty robust. I don't want you to have to learn it though. I will say, in Google Slides, I talked about why do I think it's really great. If I want my students to line up, I can just insert my equations easily, and I can slide them over, use the power of slides to align them. When I was in 3rd grade, I had to turn my paper sideways, so I lined things up correctly. This is the digital equivalent, and it's much better than that. Also, like practice plotting, I can insert a blank graph, have my students label the axes, and then after that, I can drop out some circles and have them practice plotting these points if I want. So that's a really great way. And a pro tip here is if I want to move it, I can hit the shift and then the arrow key, and my objects in Google Slides move really slowly and more fine-tuned. So that's if I hold the shift up, it moves around. So that's great where they can practice plotting, and then they can do Desmos to check it. So here, if I click on here and extract that graph, then I can actually see what check my own work. So I can extract it. I've already plotted those points in there. My students can then check along those points. What do they look like? And then reinsert that graph. So I think Slides is a really great way for them to work, and they can practice all of those labels. The Google Forms, I think, is where it's really awesome for teachers to be able to save their time and have students be able to respond. So you can put graphs as questions. I can have a lot of different things in here with anything I would really do on a piece of paper, I can do in Google Forms for a quiz or a test. And then you can see here that once I made it, so it's easy to make these questions. I'll jump into the editing part. So if I have Equatio installed with a premium account, then I can just go ahead and put math in here by just clicking on the little blue Equatio button. And the power of the Chrome extension is it's the same user experience no matter where you're using it, which again, from docs to slides to forms to sheets, The Google add-ons have different styling, so it looks slightly different. When GMath, each form had a different flavor. Now it looks the same, so students want to be able to, as a teacher, if I want to make this question, I click on the Equatio button, and the user experience is exactly the same. So it's really great for me to put questions in. I can do speech to bring my questions in, but for my students to be able to respond, I think that's a really powerful point here. So I did a different one, which was like a pre-algebra problem for my students. So if I wanted to put in, like I have my student's email address in there, and so I could put something like promises fulfilled at texthelp.com. And so there, after my email address here, I want to do the next step in simplifying this expression. So notice I say the next step, there are lots of keys that could do this, but I might be working on what does a simplification look like. So I do the equation editor, I can do 2, and then parentheses 2, and then dot for multiplication. I can also, if I do multiply, it comes up with the same multiply with the symbol or with the dot, 5, and I can even highlight that whole thing and hit the slash key to put it over something, so over 4, and I can insert that as my response. So for me, that's a really nice way for me to work on that. And then this quadratic problem, I would want my students to maybe do with handwriting. I'm going to show you something slightly different here, which is the Equatio mobile part. So you might notice that this is a little input thing. So I have my Android phone right next to this, and if it's going to work, that I'll be able to see it on my screen. And so there we go, that's my screen. And so I can just go to m.equate.io. And if I click on that, this is literally mirroring my phone, it's going to show me some of where I have Equatio open. So notice that I have this Equatio is open here. I click on this pre thing. Now this is going to be my like input tool. So if I want, I can click on the handwriting part, and now I can just draw on there. So I'm going to say, well, that's going to be 3x squared equals 24. And I'm going to say x squared equals 8, and then x equals plus or minus the square root of 8. Literally what I would do if it's a piece of paper. You also get to see my bad handwriting, and it thinks most of that, like it thought my x was a y. I could have changed that, but you can see in the essence of time in the demo, it plugs it in there exactly, and I submit that so my students can literally just handwrite on one of their phones or an iPad. And then for me, when I look at it on what does it look like, my responses comes in and it just shows it directly in there. So I can see that for me, what does that look like? So it's a great way from a formative assessment side for me to see that, but also for me to see what those responses look like in my spreadsheet. So if I look in my response spreadsheet, there'll be these URLs, which is great because then if you use Flubaroo, I can automatically grade that for correctness. But if you don't, the beauty is you click on the little Equatio icon again, and then we'll take and make all of those into our Equatio images. And so I'll be able to see all these in a spreadsheet and just be able to assess really quickly, so that you'll see that those pop in, and now that those are the pictures. So I can see all those directly in my spreadsheet, and now if it's in a spreadsheet, I can assess much quicker, and I can leverage the power of technology to get my assessments back. So that, I think, is just a really great way for me to make things digital if I can. So you might notice on my app over here, it noticed that I opened it in this spreadsheet, so I can insert from my spreadsheet. The other part is from that, I can also just take a picture and submit that in. So if I had written this down on a piece of paper, I'll just show you here. If I want to put that question, if I take my camera from my phone, I can use, I had it down on a piece of paper here. There we go. I can just take this and I could submit that as my response. I can save that as an image and just submit literally a picture. So something was handwritten on a piece of paper. Now I can submit that as a Google form response. So I think that's super cool. On top of that, if I fire this open and do the same thing, I can, from my picture that I wrote, let me crop that down a little bit, and I can save that as the math. So I can try to figure out what is my math from that handwriting and submit that as my response. So literally, if I did it on a piece of paper, now I can make it digital. Now I can leverage that workflow and just makes life easier for me as a teacher and have my students to respond. So I think that's a great thing to make it easier to work for me as a teacher, and then for students to be able to communicate their thought process. One of the things I want to get into questions, but the Equatio map space, it just makes it so I can make any of these things. Like if I have some algebra tiles, I can easily pop open this Equatio map space, share it with my students, easily integrates to Google Classroom. If I want to share this, I just make a copy for each person, make a response, and then it'll give me a short URL, and I can share it with Classroom, and my students automatically get to open that up. So I think that's just a great idea to be able to make work. I'll just show you here as well. Like when my students, when this pops open, you'll see the image pop in the spreadsheet. So again, it's just a great way to make it so I can have students who submit something physically into Google Forms. So it's great to make it digital on that aspect. That's about my time in terms of demoing. I want to see if there's any questions that are open there or anything else that I might be able to address. So thank you all for listening, and I really am so happy that you spent part of your Saturday with me, and hopefully the promises of Equatio, the promises fulfilled in there to be able to make that math digital, and hopefully it'll justify everything that you want to do in there.
Hi, John.
Hi.
Great session, and I thought that I knew a lot about Equatio, and Lori and I are over here, and you're showing things, and our minds are just being blown. All of the things I didn't even know that Equatio could do are absolutely incredible. The comments are pouring in. People are just in awe of all of this. And Kaylin had mentioned in the back channel that the premium is free for teachers.
Yeah, totally. Just go to texthelp.com free for teachers, and you can sign up. And then you get all those premium features. I will say it does take about 6 to 12 hours to populate your license through. The easiest way to get those licenses after you sign up free for teachers is uninstall Equatio and reinstall it, and then you'll immediately get those premium features back after you submit.
Yeah, the buzz is going crazy here, and Lori had mentioned something. She was a STEM teacher for many, many years in the classroom, and she said, I wish every single teacher would use this because it would make a world of difference to the students, because we know how much students struggle with some of these things. So this is just absolutely incredible. We do have some questions that came in, so let's go ahead and start addressing some of those, John. And I know we may not be able to get to every single one, but we are going to try here today. Let's see here. Could you give an example of how you would use Equatio in very early grades?
Sure. So some of the very early grades, I would do something in slides, which if this is a little bit more complicated, but if they were going to do some of those examples, slides would be a great thing. Like maybe they're even doing some basic addition. I could do speech input, and 3 plus 4 equals 7. And so they could just speak that math and then insert it. So they're like, my daughter thinks I make, actually, she's 4, she thinks I make a drawing app as well. So like that's a great way for them to get something in a slide. But this Equatio math space is just a great way for them to build some things as well. So I have some other examples, but I'll just build a new one quickly. So with this Equatio math space, you can give students manipulatives. So I can give them a circle, and then I can just copy that, and I can just fire those out, and I can say, well, there's 4 of them. So I can do some counting discs. Maybe I want to have 12. So I can copy, paste those out, and then do it again. Paste them out. So now I have 12, and they could start about how to group them. So I can literally just share these and say, show that 3 divides 12. And so if I insert that, then it makes it so they can work with those things. And it's also accessible. It'll read that out to them. It'll read these shapes. So it just makes it easier for them to work digitally.
Tiffany submitted it's more of a comment, but I think it's a great point along with what we're discussing right now. Of course, she says, this is absolutely fantastic. She continues, this will be a great tool for working with my primary students with numeracy.
Totally. And some of those things we built in, I have these shapes. I can have some like fraction bars down here at the bottom. So if you were talking about like fraction bars, you can just drop them in, and then you can shade below. So it's like one of those things where they can represent their thoughts working in here to make equivalent fractions. Or I love the open middle problems. And so I've made a bunch of open middle problems. So literally these are templates I can share with people. And we're working on making that easier to do as well. So if your colleague in your co-teaching makes one, they can literally just click on this button, and then they can make a copy for you and share it over.
Oh, wow, that's awesome. You know the teachers don't like to reinvent the wheel.
No, totally, I agree. So I reach out to my Twitter people all the time. The PLN digitally is awesome.
So we're going to jump from early learners. Now we're going to go to AP Physics here. This question is from Nader. Does it have AP Physics laws and equations stored in as you showed with chemistry?
I'm at work. There are some. I think you said his name was Nader. Send them into me. Click on this thing and do send feedback. I literally just got one through Twitter on Friday, and we update every month, so I'm updating the prediction files there. I can literally, if I just show you in my Google Docs, the last thing that I was building had a bunch of formulas that I'm putting in our prediction model. So I can just continue to add them in as they come, like so as you need them. So I think it came, yeah, there it is. So I was adding these physics equations in for kinematics and for all these projectile equations. So those will be in our prediction soon if they aren't already in there yet.
Does Equatio, is it compatible, or does it work with any LMS systems, any learning management systems?
So as of last week, we now work in Canvas.
Wow.
So there's a Canvas LTI that we can do that we can extend into where all of these tools are available directly within the rich content editor. So if you build quizzes, you can build and then use that to work with SpeedGrader afterwards. So anywhere that you can create content in Canvas, you can actually use all of these UDL tools and your students as well. So it's just really great for them to be able to interact, and you can see the student responses. So
John,
we work directly in Canvas.
That kind of goes into a next set of questions that we've received, and this question was posed by a variety of people in different forms, but and overall they want to know a little bit about, they know how to get it for themselves as a teacher, but how do you get this to your students?
Sure. So the free part works in Docs, and most of the other integrations after that require a premium license. And so you can contact us through, you can contact me through this Equatio feedback. But the most thing is if you just email u.s.info@texthelp.com, that will we'll direct you to your sales rep, and we can get those in there easily. We do pilots and all these things. Really, I want to be able to empower students. And so it's a great way to bring those in and see what it's going to look like. It comes down to be as low as $1 a student, and even cheaper if you have Read and Write as your school district. And we have millions and millions of users of Read and Write. So that's the best way that you can get that access.
Okay, that's incredible, and maybe something to also share with the principal or district leadership as well. Would you agree, John?
Definitely, and I think that's where we see this groundswell of work, is that we work with a lot of big districts now, and Equatio is just over a year old. We launched last year, April 4th. By the way, happy Cinco de Mayo, as we said, and we have over 1 million users now. So there's obviously it's a huge pain point, and we feel like we're doing a good job of addressing it.
And I know a lot of our clients here at Simple K-12 are using it on like a district or school level, and even with our solution, it's just one of those things when all of the teachers and all of the students are on the same page, singing from the same hymnal. It makes such a difference in the classrooms versus kind of those individualized classrooms using it here or there.
Totally, and I think for me as a teacher too, like my coworkers, I would show their students, and they would be amazed by the responses they get from students. So that for me was the proof in the pudding. Like when students get engaged in the work they use with it, is really, for me, it engages the learning and really amplifies the classroom. And that's what makes it easy to convince an administrator or a district level person why it's useful, because the students really love it. So I think that's the biggest use, is get it in student hands.
Let's see, lots of questions asking about more in-depth training on Equatio, also asking questions about the Read and Write and the Fluency tool. So in just a minute here, I'll show you how to access some that we already have on file. Let me see, John, if there is another one here for you guys. Let me see here. Just to confirm, you don't need a Mac to use these programs,
no,
correct?
I normally am on a Chromebook, but I can't present with a Chromebook on GoToWebinar. So normally my daily driver is a Chromebook. I use it on Chromebook. We optimize for Chromebook. You can use it on the Chrome, anywhere you have the full Chrome OS. So Mac, Windows, anywhere it works best in Chrome.
Okay. I want to show folks where to get some of the other webinars, and then, of course,
Sure.
the questions from the beginning on the certificates of completion. So I'm going to go ahead and move to that right now.